There's something special about water going in and out of a cell. And it deals with this concept of things being hypertonic, isotonic, and hypotonic. Basically, what we have going on here is that there is a cell and there is a container of liquid. The cell gets put into the container of liquid. Around the cell is a cell membrane. Okay, so around the cell is a cell membrane. That cell membrane, remember, has aquaporins in it. It will let water pass back and forth from the cell to the liquid inside the container, and from the liquid inside the container into the cell. Now it'll let water pass, but it won't let the things dissolved in the water. Most commonly thing dissolved in this situation is salt. Now the idea here is that within your cell, right, you have a fluid. It is a certain percent salt, that is the solute dissolved in the water, and a certain percent water. Now, when you have all of something, you have 100% of it, right? Can't have more than 100% of something. Most you can have is all of it. So the percentage of the solution that is water plus the percentage of the solution that is salt, or if you're talking about iced tea, that is sugar, etc., together they have to add up to 100. So if it's 70% water, it's got to be 30% solute, or the thing dissolved in it, the salt or the sugar, in order to add up to 100. 70 plus 30 is 100. If it's 85% water, the solution, then it needs to be 15% solute, the thing dissolved in the solution, because 85 plus 15 make 100. Now, those percentages, that percentage, that 15% or 30% or 50% or 5%, that is the solute, is the concentration. Now, remember, we talked about concentration, that diffusion is what happens when something moves from a high concentration to a low concentration. We use the perfume illustration, high concentration of perfume molecules, where you first spray it, they spread out. That concentration of X number of perfume molecules per piece of air, per little bit of air, gets lower and lower as it spreads out. In the same way, if you have a high percentage of solute, the salt or the sugar, on one side of the membrane, and a low percentage of the solute on the other side of the membrane, then the water is going to travel towards that higher concentration. Now, why does that happen? Well, it wants to be equal, right? But when the higher concentration of solute hits the membrane, in this case, the cell membrane, it can't get past it. It's selectively permeable. It'll let water through, but it won't let the solute through. So the only way to decrease the concentration where it's higher, you can't subtract solute, so you have to add water instead. And that's what creates this idea of the water traveling across the cell membrane. Now, if the cell inside here has a high concentration of salt, and the water that it's in has a low concentration of solute, then that water is going to travel into the cell. See, if the level of solute is lower in the water than it is in the cell, that's a hypotonic solution. The solution has a lower solute than the amount inside the cell. If the amount inside of solute in the water has a higher concentration of solute than the cell, that is a hypertonic solution. Hypertonic, you get hyperactive, you're overactive. Well, now you're oversalted. Okay? So if it's oversalted or hypertonic, that means there's more solute in the water and less in the cell inside of it.